Chapter 5, Lesson 7 is graphing on the coordinate plane. Here we want to draw triangle XYZ with vertices x at -3, 2, y at 4, -2, and z at -3, -2. So when we graph, we plot the points. So we have -3, so that means we're going to go to the left 3, comma, +2. That means up 2. So this is x. Y is at 4, -2. So 4 to the right and down 2. That's -2. So that is y. And z is -3, -2. So we have go to the left, -3, and down -2, and that is z. Okay? Now when we connect the points, it makes a triangle. Very good. So the next thing we want to do is find the area of the triangle in square units. Okay? So this, in square units, that tells us what we are labeling it. Okay? So here's the formula. Area is equal to 1/2 base times height. Area is equal to 1/2 base times height. That is our formula. So we have to look over here to see what is the base. So the base down here is how many units? 1, 2, 3, 4, 5, 6, 7. That's 7 units. Up here, we want to find the height, which is 1, 2, 3, 4 units. Is everybody with me? So now we just substitute in. So the area is equal to 1/2 times the base, which is 7, times the height, which is 4. And now we just multiply straight across. Here we can go ahead and put these over 1, just so you can see you're just multiplying fractions, right? What do I do before I multiply fractions? Very good. So we can simplify 2 divided by 2 is 1, and 4 divided by 2 is 2. And now we just multiply straight across. So 1 times 7 times 2 is 14, over 1 times 1 times 1, which is 1. And of course, 14 over 1 is just 14. Now our units are square units. So you can write units squared. So now we are going to graph ordered pairs. Please write this down. To graph an ordered pair, you're going to draw a dot at the point that corresponds to its coordinates. All right, for example 1, we're going to graph point M at -3, 5. Now, when we look at the ordered pairs, of course, the x value tells me the left and right. If it's negative, we go to the left. If it's positive, we go to the right. And the y value tells us the up or down. If it's positive, we go up. If it's negative, we go down. Very good. So when we are graphing, we want to keep in mind that we will always start at the origin. Then we will graph the x movement and then the y movement and then plot the point. So here we're going from the origin, and -3 tells me that we're going to go to the left. Now let me just put a dot here. So the -3 tells me that we're going to go 1, 2, 3 units to the left. And then the +5, the y value, tells us that we're going to go up 1, 2, 3, 4, 5 units, and there's our final point. Example 2, we're going to graph point N at -1/2 I'm sorry, negative 2 and 1/2, comma, negative 3 and 1/2. And once again, we need to start at the origin. Okay? So when we start at the origin, there we are right there. We're going to go to the left 2 1/2, so that's negative 1, 2 1/2. Does everybody see it's right in the middle? And then we're going to go down 3 1/2, because that's a negative 3 1/2. So we're going to go down 1, 2, 3 1/2. Does everybody see where that point is? It's right in the middle. Does everybody see that? Here, we're going to graph these. Got it. So we want to graph and label each point on the coordinate plane below. So here we're going to graph point P. So point P is at negative 2, comma 4. So starting at the origin, we're going to go to the left 2, and we're going to go up 1, 2, 3, 4. So right there is point P. That is negative 2, comma 4. Then we're going to graph Q. Q is at 0, comma negative 4. So starting at the origin, what does that 0 tell me? We don't move at all on the x value, on the x-axis. Very good. So we start at the origin, we stay there, and then the y value tells us we're going to move down. Very good. So that's 1, 2, 3, 4, and here is point Q. So for R, we're going to graph negative 1/2, comma, negative 2 1/2. So again, we're going to start at the origin. We're going to go to the left 1/2. Now remember, 1/2 is between 0 and 1, so it's right in the middle. And then we're going to go negative 2 1/2. So that's down 1, 2 1/2 is right in the middle. Okay? So that's going to be R. And then finally for S, we're going to graph 4 1/2. That's 4.5, right? So 4.5 is also a half, comma 1. So starting at the origin, we're going to go to the right 1, 2, 3, 4 1/2, and then up 1. So here is S. So now we're going to graph reflections on the coordinate plane. So here, make sure you write your heading. Graph reflections on the coordinate plane. Here it says you can graph points that are reflected across the x-axis and the y-axis. Okay? You just have to keep in mind, or just remember, that if we are reflecting across the x-axis, which value becomes the opposite? The y value becomes the opposite. If we are reflecting across the y-axis, which value becomes the opposite? The x value becomes the opposite. Very good. Let's write that down. So when we reflect over the x-axis, the y value becomes the opposite, and when we reflect over the y-axis, the x value becomes the opposite. Okay, so here, if I'm looking at this graph right here, it says we're going to graph 2, comma, negative 4, then graph its reflection across the x-axis. So here, A is at 2, comma, negative 4. So A is at 2, comma, negative 4 right there. Now, if I'm reflecting across the x-axis, that means that the y value is going to change to the opposite. So the new point is going to be at 2, comma, positive 4. Is everybody clear with that? Now, I want you to notice something about this A and this A. Do you notice anything? Anything there? Good. So here, this A is the original. This A has that little apostrophe, okay? You will hear me call it a prime or a composite, okay? That means this is the reflected point. Is everybody clear? It's A prime or A composite. Let's write that down. All right, so this notation right up here with A with the apostrophe on it, that is a notation to signify the reflection of point A. And you will hear me refer to it as A prime or A composite. So for example 4, we're going to graph B and then graph its reflection across the y-axis. So here, point B is at negative 1 1/2, 1 1/2, comma 3. So 1 1/2, comma 3, negative 1 1/2, comma 3 is right there. Then we want to graph its reflection over the y-axis. So if we're reflecting over the y-axis, the x value changes to the opposite. So here, the x value is going to be a positive 1.5. So now we have 1.5. So it's 1 1/2, comma, positive 3. And here is your B composite. I also want you to notice here how many units away the reflected points are from the given axis. So here we're reflecting over the x-axis, and A is 1, 2, 3, 4 units away from the x-axis. If I count to see how many units away the composite point is, a composite, that's also 1, 2, 3, 4 units away. Is everybody clear with that? Same thing with B and B composite. Here B is 1 1/2 units away from the y-axis, and B composite is also 1 1/2 units away from from the y-axis in the opposite direction. Let's do our got it. So we want to graph C, which is negative 1, comma 5, and then we want to graph its reflection across the x-axis. So if I'm reflecting across the x-axis, which value is going to change? The y value. Very good. So the y is going to change to the opposite. So here, C composite is going to be negative 1, comma, negative 5. Is everybody clear with that? So let's go ahead and graph it. So we're going to first graph the original C, which is negative 1, comma 5. There's C. And label. And then the composite point, or the reflected point, will be negative 1, comma, negative 5. 1, 2, 3, 4, 5. And here is C composite. For for letter F, we're going to graph point D, which is at 2, comma, 3 1/2. So D is at 2, 1, 2, comma, 3 1/2. So that's 1, 2, 3 1/2 right there. That's D. Now we want to graph its reflection across the y-axis. If I'm reflecting across the y-axis, which value changes? The x value changes. Very good. So my D composite then, D composite will be negative 2, comma, 3 1/2. Got it? So here, negative 2, 1, 2, comma, 3 1/2. 1, 2, 3 1/2 right in there. So that is D composite. So this one, you guys, example 5, you don't have to, just watch and pay attention, okay? Mr. Martin is using a coordinate plane to design a logo. He graphs points at 2, comma 4 and at 2, comma negative 2. So he graphs a point at 2, comma 4, which is right there, and he graphs a point at 2, comma negative 2. which is right there. Okay? He reflects 2 comma negative 2. He reflects 2 comma negative 2 across the y-axis. So if I'm reflecting across the y-axis, which value is going to change? The x value is going to change, right? If I'm reflecting over the y-axis, the x value changes. So that new point is going to be negative 2 comma negative 2. So that's negative 2 comma negative 2. So there's my new point from there. Then he's going to take that point and he's going to reflect that new point across the x-axis. If I'm reflecting across the x-axis, that means that the y value is going to change to the opposite. So here, this is going to become negative 2 comma positive 2, which is right there. So here, what kind of figure is this? This is a quadrilateral, but a special kind of quadrilateral. It is a trapezoid. Okay? All right. Miss Shaw is drawing a map of her school. Her room is at negative 3 comma 4. So let's graph negative 3 comma 4. So negative 3 comma 4 right there, that is her room. Let's just call it R. Okay? And the gym is at 3 comma 4. So the gym is over here at 3 comma 4. There's the gym. Now the library is a reflection of 3 comma 4 across the y-axis. Okay, so now this is the library's reflection of the gym, right? So if I'm reflecting the gym 3 comma 4 over the x-axis, which value changes? The y value changes, right? Because we're reflecting over the x-axis. You see? So the the library, let's write this down here. The library will be at 3 comma negative 4. Very good. So 3 comma negative 4 right there, that's going to be the library. Now that point, that library, 3 comma negative 4, that point is going to be reflected across the y-axis to graph the office. Okay? So that's going to reflect over the y-axis to be the office. So if I'm reflecting over the y-axis, which value changes? The x value changes. Very good. So the office then will be what point? Very good. Negative 3 comma negative 4. Perfect. So the office, negative 3 comma negative 4, is right there. Very good. What figure is graphed on the map? So here, this is a rectangle. Very good. And we know it's not a square because it does not have all equal sides, right? And you know this, the length of the sides just by counting the squares. So this is going to be 1, 2, 3, 4, 5, 6 up here. And this is 1, 2, 3, 4, 5, 6, 7, 8 right there. That's how you find the distance of the lines on the coordinate plane.